This presentation is on what is object-oriented programming. Not just object-oriented programming for PHP, but object-oriented programming in general. The key thing is, surprise, surprise, objects. Now, what is an object? An object is going to be a holder for all the variables and logic that we would use in a program. In procedural PHP, it's standalone code. We define a function, we call a function, we set a variable equal to something. We're not going to do much of that in the object-oriented PHP or object-oriented programming at all. All of the logic and variables will live inside of these objects. Objects contain related variables and functions. And by related, this is a logical concept. We're going to put things together that make sense to be together. I'll have some examples later. Some of the key concepts are encapsulation, inheritance, and something called polymorphism. I have encapsulation and inheritance highlighted here because they're what we're going to cover in this class. Polymorphism is not implemented very well in PHP, especially as compared to other languages like Java, and it's rarely used. The key concepts of encapsulation are going to be what we set up here. We're going to try to keep logic and variables together, things that are related to each other. The other concept is something called inheritance. This allows us to put things at a high level of abstraction in our program and inherit down methods and variables we might need in a lower end of abstraction. Basically, it's like one function inheriting properties and logic from another function, and you'll see more of this as we go on. Here's some key terminology. Getting used to this is half the battle, but all of these concepts that I'm going to talk about are going to be introduced again and again throughout all of the presentations that I'll give with code. Functions are defined inside of an object. In object-oriented speak, they are called methods. I'll use the terms interchangeably. For all practical purposes, functions and methods are the same thing. Variables can be defined within an object and not inside a function. Those variables are called properties of an object. Sometimes they're called attributes, and there are a few other synonyms, but conceptually they're properties of the object. An object is built based on something. It's built, or the key word here is instantiated, from a class. Now, a class is something that defines what is contained in an object, the various properties, the various methods or functions that are in an object. The class will serve as a definition of how to build an object. A class can inherit properties and methods from another class. An abstract class can be inherited by another class, but it cannot be instantiated by itself. More on that later. An interface is another key thing that we're going to build with object-oriented programming. It's a special object, if you will, that can contain constants and method definitions. Not methods with code or anything, but the method definitions. And these are implemented. That's a key word. They're implemented by other classes. Now, if you're thinking to yourself, oh boy, I didn't understand any of that. This is just your first pass at seeing these words. They're important to know as we learn object-oriented programming. For those of you who have programmed in other languages, like Java, that are object-oriented, they'll be familiar to you. Let's look at this and make this a little bit simpler. This is an easier way to think about object-oriented programming. This is my definition. Objects are defined by a meaningful name. We give something a name, and that name is used to keep related functions and variables together in one place. Here's kind of a conceptual example. A payroll object might contain a variable that holds a check number for a check we're going to write, and it might hold a function that would calculate the withholding tax on a paycheck. This is a function about payroll. The variable, or a property, is a check number. That's something about payroll. So things that go together. Conceptually here, we wouldn't refer to check number as a variable all by itself. It would be payroll, and then an arrow here to say the check number that's on the payroll object. Or over here, the method or function, the calc withholding tax function, is on the payroll object. So we'll be doing a version of this when we code to say where the variable or the function lives. We won't just put these by themselves as we do in procedural PHP. What's missing in PHP compared to other object-oriented languages? PHP's data is weakly typed, which means we don't give a specific type when we declare a variable. We don't say this has to be an integer or this has to be a string or a date. PHP does its best to figure these things out from the data that's contained in the variable. PHP's objects are not explicitly type. Like in Java, you might say, oh, my payroll is of type payroll. And you can't do that in PHP because we don't type our data, and the object essentially becomes a kind of data. There's no automatic object detection that can be very useful to have with polymorphism. It causes a polymorphism problem, if you will. There is no way to instantiate an object of one type into an object of a supertype. A supertype is a class that we inherit from. In Java and these sorts of object-oriented languages, we can stuff a lower-end object, lower on the inheritance chain, into something that's higher on the inheritance chain, and then deal with it through object detection. You can't do that in object-oriented PHP. Functions do not enforce a particular data type that must be returned. When we define a function in our object, we won't be saying this definitely returns a string or this definitely returns a double or an integer, as you might do in something like Java. So those of you coming from C++ or Java to PHP in an object-oriented way are going to have to get used to certain things not being there. If PHP is your first object-capable language, then you won't have to unlearn anything to use it.